Welcome, folks. Come get settled in. We'll be starting here shortly. Good to see a lot of familiar names here. See you, Catherine. Great. We will go ahead and get started. Thank you all for joining us. For those of you who don't know me, my name is Vaughn Woodruff. I am the Vice President of Regulatory Reform at the Interstate Renewable Energy Council. And I'm joined today by Mari Hernandez and Shay Banton, who will be sharing a lot of great information related generally to distribution planning and specifically to Maine. Now, for those of you who aren't familiar with IREC, we're a national nonprofit organization. We have three primary programs, workforce development, local initiatives that focuses on streamlining permitting and inspection for local governments, and then the regulatory program, which focuses on helping states regulate their electric utilities, and Mario will get more into that. As an organization, our overall mission is to build the foundation for the rapid adoption of clean energy and energy efficiency to benefit people, the economy, and our planet. With that, I will turn it over to Mari, who will be talking a bit more about our regulatory program.
Hi, everyone. Thank you so much for joining today. So yeah, I'm just going to go through a few intro slides here, and then we'll get right into it. So as Vaughn starting to talk about the regulatory team, we help states and territories regulate their utilities to ensure that distributed energy resources can rapidly and equitably decarbonize the grid. And we do this through 5 different tracks you see here on the screen. We advocate for tools that can support smart DER siting, like hosting capacity analyses. We promote better utilization of DERs through innovative DER integration strategies. We design processes that enable rapid utility approval. We ensure utility accountability after updated rules and practices are in place. And then we push for more holistic and equity-centered grid planning to create a clean and equitable grid. And most of our work, you can see on that slide, sorry. Most of our work over the past couple of decades is focused on the interconnection of distributed generation to the grid. And then what we realized fairly early on was that as adoption of DG increased, there would be more grid constraints that could slow down the interconnection process, no matter how good the state's rules were. So our team at the time, along with Sandia National Labs, developed a concept paper on integrated distribution planning in 2013, which highlighted how a proactive planning approach could help to facilitate the integration of high penetrations of DG. And today, integrated and proactive planning efforts are much more widespread, as you all know, and as you've been working on in your state or states. I know it's not just Maine folks here today, and welcome to everyone who's online with us. While IREC doesn't cover every aspect of IDP, we are excited to highlight particular concepts that we believe should be incorporated to enable better grid planning and the equitable distribution of costs and benefits. So Vaughn already, you can stay on this screen. Vaughn, you already did a quick intro, just really quickly for those who just joined.
Yeah.
Shay Banton. Shay Banton is a regulatory program engineer and energy justice policy advocate based in Washington, D.C., and they've been with IREC for about 2.5 years. I'm coming to you from Portland, Oregon. I've been with IREC for over 8 years now, and I'm the director of the regulatory program. And then you already heard from Vaughn Woodruff, who's our regulatory VP. And just for a little quick fun thing, I tried to get ChatGPT to do an intro like you would do a band intro, like if I was on the stage and I was a musician. And what it came up for Vaughn was pretty funny. It said, I just put in your bio, Vaughn, and what it came out with was, from the rugged coastline of the great state of Maine, he's the lobster-loving legend who keeps our regulatory rhythm tight.
No one's told Pittsfield that we're not on the coast, so.
Right. So I kind of love that. It didn't have a great one for you, Shay, in DC. It didn't really make sense to me, so we can go to the next slide, but I just thought that one was funny. So just some quick logistics. We're going to use the chat box to submit questions throughout the presentation parts of this, but during the Q&A after each section, we'll answer any that haven't been addressed as we go along. So if there's some sort of clarifying question we need to stop and address during the presentation, that's totally fine. But then during the Q&A sections, we'll allow you to come off of mute. You can use the raise hand function. You just have to click on the react on the bottom of your screen and you'll see a raise hand function there. And then you can come off mute and ask any questions or provide comments at that time. Also, closed captioning has been enabled, so you can select show caption at the bottom of the screen if you want to use that. And then this is a more recent thing, but we do not allow AI note takers or bots to participate in our webinars. So we'll just remove those if we see any of those come up. And then lastly, we'll be sharing the slides and recording with all registrants within the next week. And we can go to the next slide. So just quick on the objectives, we want to provide an overview of proactive hosting capacity analysis, including how it can be integrated into grid planning processes. We'll describe a proposed cost allocation framework that distributes costs and benefits more equitably among interconnection customers and ratepayers. And after each section, we'll discuss how these concepts can help to inform grid planning efforts in Maine and elsewhere. And next slide. So this is our agenda for today. I'll start with some just quick level setting on IDP and the objectives that we advocate for to guide the planning process. Then we'll move on to details of proactive hosting capacity analysis and then the proposed framework for allocating cost when using proactive hosting capacity analysis. And next slide. So as you're likely aware, conventional distribution system planning has typically been centered around safety, reliability, and resiliency with core objectives such as affordability, and in more recent years, grid modernization and electrification. As adoption of distributed energy resources increases and utility capital expenditures on the distribution system increase, we are seeing many states shift to integrated planning, which can allow for better oversight of utility expenditures, greater transparency into grid planning, and more meaningful stakeholder engagement, and hopefully better outcomes as well. Let's go to the next slide. So the concept of integrated distribution planning encompasses holistically planning for grid needs in a way that goes beyond just basic customer service, reliability, and affordability, incorporating objectives that address climate change, decarbonization, DER utilization, and building and transportation electrification, with the overarching goal of ensuring all of these things are done in a way that supports energy equity. We believe that proactive hosting capacity building should be added as an objective, which we'll get more into later, but it is essentially a method of estimating the amount of new load or generation at a specific grid location under planned and forecasted conditions without requiring additional infrastructure upgrades. Let's go to the next slide. So then we looked at Maine grid planning. So what you all have been working on, or a lot of you have been working on. I'm not going to spend a lot of time on this since you're obviously familiar with these, overarching principles and priorities, but we wanted to compare this with the objectives I just laid out in the previous slide. So we took this and added that direct comparison in the next slide. So let's go ahead and move to the next one. So, in the July 2024 Commission order, you have your 3 priorities: the reliability and resilience improvements, improving data quality and integrity, flexible management of DERs and load, and then those overarching principles of affordability and facilitating these, states' climate action and greenhouse gas emission reduction goals and policies. And then the other objectives we included in there, the environmental equity and environmental justice impacts. You have that in there as well. So we know that the Commission required the utilities to describe how these impacts were integrated in the planning process and investment prioritization and other, things that they were using to address those considerations. So we kind of laid out the main integrated grid planning on the left side, and then the framework we are suggesting on the right side. And then we'll do on the next slide, we'll start to look at how those kind of connect. So this shows the alignment between Maine's integrated grid planning objectives and the ones we shared. Though we haven't been involved in this proceeding, it's clear that there's been a thoughtful dialogue and stakeholder input so far, and a lot of good learnings from other states have been incorporated. We know you've gotten many good presentations from other folks and kind of some sharing of best practices. So it was really good to see those connections. And the only real outlier here is proactive hosting capacity. We'll go to the next slide. But what we're hoping to show is that proactive hosting capacity analysis is an objective that can help to achieve Maine's overarching principles. So we'll dive into the details of PHCA. It's a little cumbersome to keep saying proactive hosting capacity. We'll do that in the next section. But first, I know you all have a lot of understanding of, both integrated distribution planning. You're doing that in the integrated grid planning proceeding. But if you have any questions at this point, we're happy to take those. Again, you can submit any questions in the chat or feel free to raise your hand or come off mute. If you have any comments, we're happy to take those now. Vaughn's going to lead the Q&A in each of these sections. So I'll turn it over to Vaughn.
Yeah, great. Linda.
So I'm just wondering if you guys ever give feedback through the Maine Public Utility Commission's, requests for information and those kinds of activities where this type of input would be very helpful in guiding the PUC in terms of how to interact with the investor-owned utilities.
Yeah, I can start with that one. That is definitely something. I don't know if you're just only speaking of Maine, but just generally we do intervene in proceedings as well. So that is one of our main, activities on the regulatory team is we do intervention. It basically just depends on our capacity and funding for that activity. But what we've been trying to do is, I mentioned that paper that we put out in 2013 with Sandia National Labs, and we didn't stick necessarily with that work throughout. So we're kind of building up our capacity to do this work now over the last couple of years through, funding, from funders to start to work on some of this work. We didn't have that in place before the integrated grid proceeding, so we did not submit comments. Obviously, I'm sure you saw, we did not submit comments there, but it is something that we're going to figure out our strategy going forward in terms of state interventions and what that looks like and where we're providing that, those comments, or where we're providing technical assistance, because that is also something we provide on our team. So although it's not something we've done in Maine, we're starting to look at that. We are actually, Shay has been working in Minnesota to provide some comments there. There are a couple of different working groups that we've been involved in. So we're kind of starting a little smaller, but we wanted to kind of get back into this work. And so that's actually part of what we're doing here is trying to take learnings that we have and make sure we're sharing those with states. But that's a good question. And I wish we had been involved a little, much earlier in the process for you all in Maine.
Thanks, Mari. Steve, good to see you.
Good to see you too. Hey, everyone. Thanks for doing this presentation today. I just wanted to clarify that I think you characterized on the last slide that proactive hosting capacity analysis was an outlier to the Maine process. And I participated in the stakeholder discussions about the Maine grid planning process and have been involved in the follow-up implementation of it. And I just wanted to clarify that, there was quite a bit of discussion about hosting capacity analysis and with the utilities and other stakeholders. And definitely there was an emphasis on the need for having it be proactive as opposed to being static, and a need for coordination and consistency and so forth. But I'm not entirely sure exactly where that landed and what utilities are planning on doing in their grid plans, which are due in January. But just wanted to let you guys know that that was part of the discussion, and I'm definitely looking forward to hearing what you guys have to recommend in terms of implementing it going forward. Thanks.
Great. Steve.
Yeah, thanks, Steve. I did, I combed through a lot of the comments just before, um, actually before we were supposed to present last month, and we weren't able to. And I do remember a couple of sets of comments. Obviously, we weren't in the working group discussions, but that's good. That's definitely good to know. But I do remember a couple sets of comments that, or at least one set of comments that really directly addressed this and was pushing for it.
Yeah, I think it was more part of some of the stakeholder meetings that led up to the planning
Okay.
order where the utilities shared some of their hosting capacity maps, and there was discussion about how to think about it, how to include it in the grid plans. So yeah, I think it was more part of the stakeholder process.
Okay. Got it. Thank you.
Great. And we'll move on to the next section. I would recommend to folks, because we really want to make sure that this presentation provides the most value for this group of stakeholders. If you have certain questions that pop up, as Mari said before, put them in the chat. But also would love to, if there are topics that are, as we've been talking about what today looks like, if there are topics that are particularly of interest to you or angles on any of the topics that Mari discussed, please by all means throw that in the chat so we can make sure that as we hit those sections, we can focus on the things that are most pertinent to each of you. All right. Why don't we go ahead and move into the next section? With that, I'll turn it over to Shay.
Awesome. Thank you so much, Vaughn, and thank you, Mari, for the introduction. Nice to meet you all. Again, my name is Shay Banton. I use they, them pronouns, and I'm regulatory program engineer and energy justice policy advocate here at IREC. I'm really excited to talk to you all about proactive host capacity analysis, its use cases for IDP, and in particular, its utilization and cost allocation. But first, we're going to start with some general definitions, just to level set across the area. Next slide. So I know we're all very much familiar with this term host capacity analysis, but then again, just really want to make sure that we're on the same page. Host capacity analysis is typically a static analytical tool that evaluates current loading conditions and estimates how much new DER can be deployed in a particular segment of the grid. There are also applications for load as well. So you can also estimate how much new load can be applied and developed in a certain area based on those current loading conditions and equipment thresholds that exist there. There are two primary use cases that host capacity analysis is used for. First is the most prevalent one, customer prospecting tool, and second is utility screening tool. Next slide. So when we think about, customer prospecting, again, we're all probably very familiar with this, but this is a way to hopefully streamline the interconnection process by basically increasing data transparency on grid infrastructure and its barriers, allowing developers to then provide and site their projects in areas with existing capacity. So instead of receiving an influx of projects and having a lot of failures, the goal of host capacity analysis allows you to basically optimize the development process to those areas with most capacity. And hopefully lowest amount of review and screening and upgrades required. Then there is the second use case, which is primarily used in California at the moment, which is as a utility screening tool. So with the interconnection process having multiple steps, having, application review up front, maybe some screens that are used up right after that to ascertain whether or not the project can immediately move through to an agreement or not, or has to go into further analysis. Host capacity analysis, if robust enough and trusted enough, and developed thoroughly and with rigorous quality control mechanisms in place, can actually be used to perform a lot of those utility screening processes. And so that's a really awesome use case of host capacity and both informing developers as well as helping utilities better and more quickly process applications. Next slide. So now we have the introduction of proactive host capacity analysis. And again, sounds like what Steve said, that some discussions have been included here. But when we think of proactive host capacity analysis, we're thinking of, that same similar analytical tool that has, the same screening criteria and analyses that are conducted, but it changes some of the inputs. We'll go into detail more about that later. But you're really trying to understand not the static and current condition challenges, but also the planned and forecasted conditions. And so sorry for the note right there. Add mass definition. My apologies there. But yeah, we're really thinking about the forecasted conditions, what is going to happen in the future, what are future load profiles, future DER penetration levels that may impact host capacity going forward. So you're really trying to think into the future, and then consider what challenges interconnection customers might face in that future moment, and therefore we can start investing in those upgrades now. So that is the real reason there. There are two primary use cases for proactive host capacity. The first is as a customer engagement tool. So we think this is in alignment with host capacity tools and their efforts to promote data transparency, to increase engagement and increase efficiency of interconnection processes. By having a PHCA and performing it and publicizing it, you create a very unique customer engagement tool, which we'll talk about in a second. And then finally, we have proactive host capacity planning in particular. So there are two use cases there. Next slide, please. So there's been some limited implementation of PHCA thus far. This is a map out of on the right. NV Energy in Nevada, and you can see the little GIF going back and forth. But they included in their host capacity analysis tool the inclusion of a forward-looking forecast of load that is then performed in the host capacity analytical tool and output at different time increments. So here you can see as that slider moves, the red sort of the colors that indicate capacity on the circuit change. So in general, this proactive host capacity tool is basically increasing visibility into those future conditions. But what's the real underlying rationale and usefulness of this? And this is where customer engagement becomes really crucial. In discussions about developing frameworks for proactive host capacity planning procedures in other territories like Minnesota, there was a quick realization that as much as utilities and regulators want to, incentivize, the development of new projects, they also definitely do not want to be building too much infrastructure where projects aren't actually going to be sited because utilities aren't developers. They don't know the ins and outs of the trade, the land use constraints, geographical challenges, all these other maybe local permitting issues, those things that really impact development. And so there's definitely a need, especially in the larger project space, to have communication back and forth between the industry and the utilities during the integrated distribution planning process to better understand what areas currently lack capacity under future loading conditions that are likely or could actually benefit from the new investments and where development of new projects could actually occur. So as an engagement tool in providing this transparency upfront, it allows for that dialogue through different working groups to occur and ensure that whatever investments and projects are proposed are actually more than likely going to be utilized by future projects. So it's a de-risking tool in many ways. Next slide. And the one that we're talking about today, in particular, is really going to be focused on the proactive planning use case. So in general, our definition for proactive host capacity planning as an objective of integrated distribution planning is investing proactively in grid infrastructure or other enabling technologies that increase the system's capacity to accommodate distributed energy resources and thus alleviate interconnection process bottlenecks. And so, as I mentioned previously, the previous slide, by increasing transparency through a customer-facing PHCA map, you do allow kind of de-risking of some of these investments to ensure that they are going to be serving future projects that are actually feasible under the conditions of the grid, of politics in the area, of land use constraints and things like that. And so that is the kind of main use cases of PHCA. And in the next slides, we're going to start talking about what differences in the actual structure of host capacity and proactive host capacity analysis. What are those key differences in the analysis and inputs and all those things that go into them? Next slide, please. Yep. And so we're going to be examining these differences. Next slide. So we bucketized these differences into three main areas. Inputs. So those are the variables that go into the analytical model. That are ascertained from current conditions or future conditions. Then we have the evaluations and assumptions. These are kind of the core foundation of host capacity analysis. How is it actually performing? And what criteria is it addressing or evaluating the conditions under? And then finally, we have outputs and uses, which we discussed a little bit already. Let's go to inputs first. So very similar to host capacity analysis, PHC also has and utilizes geospatial circuit data. Um, PHCA is also really only useful when you do it on a sub-circuit level. We're not thinking about doing, feeder level capacity constraints because that's not really conducive to identifying where, certain equipment thresholds that could be detrimental to future development are. You do need to have that kind of sub-circuit and geospatially granular circuit data, especially for the visibility aspect. Then you also have to have your equipment ratings, mapped out. The thing that might change there slightly between HCA and PHCA is recognizing that if there are plans to change equipment, that you definitely want to account for that in your PHCA. So if you have some planning based on reliability investments, equipment ratings might change, and so you have to reflect that in the PHCA future assessment. Circuit loading. This is the main difference. So again, we have loading conditions under historical trends used in host capacity analysis. And then under proactive host capacity analysis, we have forecasted loading conditions, which will change based not only um, on what historical growth trends we've seen, but also on electrification and decarbonization efforts, right? Those are going to have significant impacts on that future-looking host capacity scenario. And then we have DER and generation. Again, existing is going to be focus of host capacity analysis today, but looking forward, we look towards forecasted DER deployment. We can talk a little bit about that, but there's a lot of research and work on identifying and creating, economic forecasting models for DER penetration and deployment levels over time, as well as, using policy objectives of the state to influence those forecasting scenarios. There's a lot of research there. We can talk a little bit more about that in the future, but that's a main component. And then finally is the concept of dependable DER. I'm going to touch on this a little bit later, but this is a very important concept that is utilized, especially in load forecasting, that needs to be utilized better. And I'll explain that a little bit later. Next slide. Looking towards the evaluations and assumptions, again, these are like the structural component of host capacity analysis. This is the analysis part of the host capacity analysis. And so under an HCA, when we look at voltage screens, you have a pretty broad range of analyses that are conducted. For voltage, you have over under voltage conditions, rapid voltage change. You may also have some assessments for voltage regulator movements and tap change movements that are there as well. In PHCA, that's not going to change. You're going to still use those same limits, depending on the standards that you design your systems to accommodate and adhere to. You then have your thermal screens. You're really focused in host capacity on continuous ratings of equipment. For the engineers here and not non-engineers here, continuous means just wires under normal circumstances, day to day. How much can they accommodate? And then there's other settings like emergency or withstand ratings that are based on fault conditions or abnormal conditions, which you don't really want to design. The DR penetration levels based on these very short-term limits. You want to focus on the long-term ability of equipment to accommodate those systems and the current that they're outputting. So for PHC, you're going to use that same continuous rating. Protection screens, this is where you start implementing those withstand and sensitivity screens. Again, won't get too much in the weeds here in terms of the protection related matters, but PHA, you're going to use those similar protection screens unless you have some maybe new grid modernization practices that incentivize more modern or adaptable protection schemes. Again, not really going to be applicable for most territories at this time. And finally, you have equipment thresholds that are going as a base of analysis. So you're going to be using your current thresholds. And like I mentioned in the previous slide, you're thinking about planned upgrades as well. So if you have upgrades that are based on certain investment decisions outside of proactive host capacity analysis that are on like a 2, 5, 10-year time frame, you want to make sure that is incorporated in your PHCA, as well as any reliability investments that are necessary based on, a yearly review of reliability. Um, um, yeah, reliability of the system under current conditions. And then finally, you have your scenarios. So scenarios outside of the, strict analytical and screening procedures in the evaluation assumption sections. Um, PHCA fundamentally is assessing forecast, which forecast have inherent risk, right? You're looking to the future, you don't know exactly what's going to happen. And so you typically create various um, scenarios to be deployed for PHCA. And that's really going to be really applicable when with DER and electrification profiles. And so you may have a scenario that has high adoption rates based on the most progressive or most optimistic output of the state policy goals, and you may have something that's more conservative, maybe based on more historical trends. And you also may have an assessment that's based on equity. So where do you want host capacity to be developed based on disinvestment practices in certain territories or certain regions and certain communities. So you want to make sure you have multiple scenarios, and those can often be crafted directly with industry stakeholders to make sure that you are accounting for all the variables that are necessary. Next slide. And finally, we have our outputs and uses. I mentioned this before, but for public mapping tool, HCA is primarily a prospecting tool. But for PHCA, it's going to be an engagement tool, which I think I already discussed. Scenarios, again, we're going to have one for HCA typically. In PHCA, you're going to have multiple because you had multiple, forecasts that were used and multiple assessments that were used. And so you're also going to have some multiple outputs to assess. You also may have them over the course of many years. As we see time horizon, you'll have 1, 5, or 10 years or whatever forecasting timeline that you like. So you would also have multiple scenarios in that case. For cost allocation, interestingly enough, host capacity analysis has been used in some territories as a pro rata discovery tool. So that is in order to determine how much new capacity a particular upgrade created, and then to basically divvy the cost of that new upgrade across the different projects that are now connecting to that piece of infrastructure. So that it's potential to be used in that case. It's only slightly been used in that scenario. In some territories, which I can walk through if people would like. But PHC and the alternative is really looking at, in our opinion, co-benefit distribution. This is a concept we'll get into a little bit later as well. But when you're thinking about future investments, you're thinking about multiple benefactors. And so you want to be able to divvy up the cost between those benefactors versus just the cost going to one group of industry, which is what host capacity cost allocation practices have been used for. And then finally, we have use. So screening and feasibility for host capacity analysis. Again, that we talked about that a little bit earlier about California using it in screening processes, and then PHCA is used for planning and investment. Next slide, please. So I know there's been a lot of information, but we have 2 more slides before we kind of take maybe a short little pause. But here we have a quick overview of what I mentioned in the input section, which is dependability. This is a not necessarily new concept. It's been around for a bit since I think 2017 in Southern California Edison, but this becomes increasingly more important when we think about proactive investments. So what this means, what DER PV dependability means, and I'll read this off here, is the amount of generation that can be reasonably relied upon, even under adverse conditions, such as cloud cover. And this is fundamental for use in planning decisions. And it makes sure that we reduce the risk of overbuilding when new loads can actually be served by existing DERs. So on the right here, you actually have a curve, a PV dependability curve from Southern California Edison. And what this is their effort to look across their entire territory and see exactly where and how reliable PV generation could be throughout the year. So when you have large amounts of PV deployment, and you obviously you have cloud cover and other conditions that may change things, but because you have such a diverse geographical region with varying cloud cover, and these feeders can also be pretty long, you can start actually creating dependability curves, which state when PV is going to be operating at some high percentile reasonable reliability rate. So maybe I think in Southern California's Edison, it's I think 90% of the time they can rely on PV to operate at this percentage of output over in a particular region and assume that in their planning decisions. And that makes sure that when they do propose, new investments into to plan for new loads, that they can actually reasonably determine that PV will actually serve a certain percentage of that. Therefore, they don't have to make as much investments. So it's a really important tool for the affordability case for customers to ensure that any proactive investment or any future investment even is the most optimal one and is accounting for basically the changing nature of the grid, this kind of multi-generation distribution generation focused grid that's interacting with the centrally sourced grid as well. So that is DR dependability, and I can talk a little bit more about that as well if anyone has questions. But final slide before I take a little short break.
Hey,
This is just
Shay,
a little, oh, go ahead.
Shay, on that last slide. So the 2019 line was the taller line curve going up there.
Yes, yes. Oh, yeah. I
Okay.
should maybe explain that. So, they there was an initial DR dependability assessment done years ago based on 2012 data, and they more recently updated it to reflect a more geographically, a regionally specific profile, as well as accounting for some additional like a percentile risk. So at first, this is a little complicated, but I'll say it first. The first curve, the lowest curve, is based off of like, okay, if we look at minimum load or minimum generation profiles across the territory, across the year, and like what is now the minimum output that we can basically rely upon for all the PV systems generating, and kind of calculating it up, and you come up with this low value that is basically averaged out across all these DER sites in a region. But they took a look at that and eventually realized after some deep investigation that that was actually undercounting the reliability of these DER sites. Minimum is not all these sites were minimum at the same time. Some were operating at minimum, while some were operating at their maximum output at the same time. So looking at just all the minimums wasn't really the best practice. So instead, they deployed more a statistical analysis, which they look at that 90% of the time, where are the PV operating in a particular region, and that allowed for that curve, that PV dependability curve, to go much higher than it was. They also did again a regionally specific SCE, Southern California said covers a pretty wide geographically and climatologically diverse region. And so they did kind of separate certain zones and look and see how the PV curve with that new risk factor changed. And there were some pretty significant changes between certain areas. And so that's also a very great way to ensure that you are both being conservative while being as progressive and as forward-looking in terms of how DR could support your grid planning and load serving efforts. Perfect. Next slide. And this is just a little bit of a summary, just showing that all these variables that we talked about previously, so host capacity, can be performed for generation and load, focuses on looking in the past, historical values, and that it could also be using DR dependability, depending on the territory, for load evaluations to ensure, again, that we don't overinvest in certain infrastructure, and PHCA then expands on this with forecasted loading conditions. It looks at both forecasted load growth as well as DER growth, and as well as known load additions. And the same goes for load PHCA as well, which also incorporates DER dependability, how much DER will serve that new load coming online. So with that, I'll move on to the next slide, title slide, but I do want to see if anyone has any quick questions or comments. I know that was a little bit, it was a little bit of a lot. Steve?
Yeah, thanks, Shay. Just, I'm not sure if you're getting to this later in the presentation. If so, just I can wait. But in terms of like forecasted DER, I remember one issue that came up was, I think somebody put in the chat the so-called CELT forecast, which is used by ISO New England, that was going to feed into the Maine process. How to allocate that DER load sort of at the circuit level or sub-circuit level as you were showing there, where do you assume that's going to go? In terms of your scenarios that you're going to develop? I think I remember some discussion about like spreading it out like chunky peanut butter or something like that was the analogy, but I'm just curious like how that's been done in other venues. Thanks.
Yeah, absolutely. So I won't be able to touch on this much, and this is also a pretty big topic. The details of forecasting DR deployment. There's efforts in traditional host capacity analysis. This is also kind of a question. You said the peanut butter spread model, which is like kind of just like spreading them across equally across the circuit, which isn't really reflective of typical development practices. There are stochastic methods, which deploy a range of different scenarios, of different deployment scenarios on different segments of the grid, clustered and unclustered and the like. So there are different ways in a capacity assessment or a capacity analysis to divvy up deployment. But when it comes to the forecasting component of it, and really trying to understand how adoption trends will translate over time in certain regions, there is, unfortunately, from our standpoint, there's a lot of questions there, and there's a lot of research being performed by groups like LBNL and applications and tools like LoadSeer that attempt to perform and map on those econometric models to determine where these DR deployments are most likely. But those, yeah, that would be more of an input into PHCA that we aren't going to be touching on necessarily today. Perfect. So I'll go ahead and move on. Vaughn, if you put the slides back up. So I know we'll have another section for questions right after this, but I just want to give a brief break in case there's anything there. But here, we're just going to go through a really short, you know, diagram of what when we say why PHCA is important in grid planning, and what challenges we've seen in other territories that are thinking about proactive grid planning, why the PHCA process and assessment is really important. So we're going to be just walking through some typical or procedures that have been done in the planning process and show how PHCA can play a little bit of a role here. So this first slide is really identifying how grid planning and management is done today. At the top, you have, I think we all know, operations and management, that of how we manage the grid today and what are the main variables that are currently informing, decision practices there. So if a new investment's needed, what are we making that decision on that investment for? So for existing system capacity in O&M, you're looking really at existing load and existing DER. So a transformer, service transformer breaks, or a recloser breaks, besides, updating it to the most recent maybe model, or recent standard in the utility, you're really focusing on serving what existing loads and existing DER are there. I know some places do consider some of those more proactive approaches or looking, saying, we know that we have some load coming on in the future, we might upgrade this a little bit higher. But typically you're really looking at, the standards approach. What do we have in our standard? What's our standard replacement procedure? Let's go to replace it based on whatever load profiles in that system. Then looking at the planning model, so looking a little bit ahead, right, in a distribution planning proceeding or procedure, we have a focus on not just enabling system capacity, but enabling future system capacity. And so here you have, recognizing that we have that existing system capacity, like what are our current equipment thresholds and system infrastructure and loading conditions, and what is going to be future load that we need to serve based on, growth patterns. And climate data, as well as what are maybe known load additions that we already were informed of. A huge development project, huge residential region being developed, huge industrial complex being built, incorporating that into the planning process is definitely a must and definitely done by, I think, almost every utility. Next slide. When we think about, the slightly next phase, like a 1.1 version of grid planning, we see utilities like Eversource and Massachusetts utilities deploying a slight step forward, looking a little bit more proactively. So they have this enabled system capacity, they have the existing system capacity, and they have this SIP program, which is focused on, investments tailored towards enabling DER growth. And it's based on what has been queued in what DER has been queued, but a little bit of a nuance there. It's not just like what is existing in the queue, it's what has been proven, what projects have been proven and shown that they are investing in going to build their projects. And they do this through basically a group study process. So they have a group study process that, assesses all these queued projects. They have this commitment period and process to ensure that the group study is evaluating projects that will be built. And then they determine what in new investments to make to enable that new system capacity for new DER, again, based off of group studies. So a little bit, there's a lot of risk reduction here because you're reliant on group studies, but there's also a lot of time delay and a limited number of projects and areas in which these projects will actually, these new investments will be made because it's based off of a limited group of projects versus like, a more forecasted holistic approach. And this is actually also how they do cost allocation in general, but we'll talk about that a little bit later. Next slide. But now when we think about our process, we're kind of building up on that and including more details. So enable system capacity is still the objective here. But now you have both known load additions, forecasted load, QDR, and forecasted DER. So it's combining that Eversource SIP process focused on enabling new DER growth and planning procedures focused on enabling new load growth and putting them all together. Next slide. And this just shows how these all map onto each other. And so you can see when you expand existing system capacity, you now have kind of these basically three columns of investigation and variables that you want to consider. Again, existing load and existing DER, node load additions, and QDER. So if those queues were managed and group studies were to ensure that they were committed projects, and then finally forecasted load and forecasted DER. So those are all the conditions. And what PHCA is going to enable us to do is basically to keep these separations known. So when you do cost allocation processes and you do all these assessments, you're going to come up with a cost of an upgrade and a cost of an investment needed to enable all this capacity. But how do you actually know how to separate what cost goes to ratepayers, to the existing load, known load additions, and forecasted load that is almost always borne by the rate base, and how do you separate the DER related cost? What's going towards new QDER and forecasted DERs? And so we will go to the next slide, I believe, and take a quick pause for questions. Linda?
Jay, that was very helpful. I may not be remembering the numbers exactly right, but when Maine ratepayers interact with ISO New England at various forum, stakeholder engagement, they typically cry poverty in terms of using better models or making better plans. My frustration with that cry is that they are investor-owned utilities who can afford to provide their investors with dividends and, you know, various payouts. And I may be remembering the exact numbers wrong, but the number of hours that they were saying they would have to add was on the order of 1 to 3 full-time equivalent positions. It wasn't 300. It was like, you know, less than 10. And so I am skeptical about the cries of poverty and inability to apply those resources. But has that been your experience when you try to go to the actual entities that are supposed to be improving their planning, is that they just cry poverty and say, we can't possibly do this with our existing staff, or, you know, what is that the typical excuse, or are there other excuses that they're using too?
Interesting. Yeah, I guess to be honest, I have heard in our interconnection work, definitely issues with resource constraints. And honestly, we will be the first to say that the introduction of proactive host capacity, as you saw the multiple scenarios and forecasting challenges that come with it, is definitely going to require additional resources. It's a complex issue, requires a complex or very educated, highly educated, engineers and researchers and staff members who are, considering all the possibilities, and running all these different analyses and engaging with developers and industry pretty consistently. So I would say that maybe I haven't heard that in particular in these conversations, since I think like Minnesota, for instance, there is a lot of engagement, or a lot of seems like staff engagement and efforts towards making these kind of things work. But I definitely see the issue that there is going to be some resource scare with the development of these new things. But this is also the grid of the future. The grid is becoming more complex, but also more resilient and also more clean. And so it's going to rely and require a lot of people to make it work. But it's not impossible. And I also kind of actually, yeah, I'll pause there. I don't want to make any other statements that I might say, but I agree that that is definitely a challenge, even if it may not always be substantiated.
And if I could add to that, Shay, I think this isn't really a utility investment as much as it is a ratepayer investment. So it is about, making sure that the tool is useful. And IREC's been involved in California with the development of their just straight hosting capacity maps for a number of years, and it takes a lot of work to get those to be accurate and useful and not just be maps that get stood up. And so I think at the end of the day, it's a value investment to consider in terms of ratepayer investment in the tools versus the ratepayer benefit that comes from them, by making sure that the infrastructure build out is reasonable and not overbuilding the grid based on scenarios that may never happen. Yeah, what are the questions that folks have? Should we move to the next slide, Shay, and maybe think about?
Yeah, sounds great. I'll let you lead this one.
Yeah. I mean, I think a big piece of this, obviously, a number of you have been involved in the ongoing process for this, thinking through what grid planning looks like, and now hearing a little bit more about proactive hosting capacity as opposed to kind of the more static hosting capacity. Yeah, what are opportunities that folks here are seeing for leveraging proactive hosting capacity for the ongoing grid planning efforts in Maine?
And just one quick question too, just to, as we were looking into this before, this was in early May. So I put this together where you had milestone 1 being complete, which was determining the model inputs. And then there were stakeholder meetings held earlier this year with both CMP and Versant. And then milestone 2 is system modeling and grid needs identification. And I had the target as Q2. So we're basically at that target. I was curious, has that already been done, or have there been stakeholder meetings about milestone 2, or is that upcoming? If anyone can share about that.
Yeah, go for it, Steve.
Yeah, I think there were some stakeholder meetings related to milestone 2 that where the utilities were presenting what assumptions they were going to use and how they were going to do the modeling and other analyses that would feed into the grid plans and getting input on that. I haven't seen um, I haven't seen anything following up from that yet. So I'm not sure when the next mile or the next step in the process is going to happen.
Got it. Thank you.
Yeah, Kiera.
Good afternoon. The governor's energy office just had a meeting with Central Maine Power this morning, and they indicated that they're anticipating holding their milestone 2 public engagement session later this month. So looking forward to that happening here in June.
Thanks for that update. Great to hear your voice. Yeah, what other thoughts do folks have on how this may either support or maybe, this is hosting capacity can be a big lift. And we know, I think CMP in the docket had highlighted its plans for both generation and load with its hosting capacity versus has some for generation. Anyone have any thoughts in terms of kind of where we are and or questions about how big of a lift it is from where Maine is to this kind of this kind of framework?
This is Susan Chamberlain. I can't find my raise hand thing. Um, but I'm with the Office of the Public Advocate, and I was interested in, is there software? Is there, how big a lift is it? How much, the prior questioner was talking about added personnel. Is it an infrastructure issue? Because obviously it sounds like a good idea to just have more information available. And I've seen other presentations where the hosting capacity maps are quite, they're just very current. They have layers of information. They do far more proactive planning than what we have. And I don't know what is needed to get from here to there.
I can get yourself on that one. That's a great question, Susan. Thank you so much for it. Um, You are correct. Yeah, there are some infrastructure barriers, but those have largely been addressed actually by many of the major systems modeling, power systems modeling software providers. So you might have heard of SIME or Synergy. Those are some very, very common. I even believe like Aspen may have it as well. But very common and frequently used power system modeling tools by utilities. And we've spoken to several of those software developers and they are currently or already have both host capacity modules within their tools that can either be purchased or added or already baked into the tools, as well as are currently working on kind of strategies to streamline the multi-scenario challenges that may come with more future forward and forecasted proactive host capacity assessments. You can do that on like a pretty somewhat static basis. You can change out things like or slightly manual, like put an input in, put a couple of load profiles in, and then switch it out for a forecasted one. So basically run the analysis twice under, or however many times you want. But they are also working on at least Synergy is specifically on, creating scenario list and processes so you can actually just run multiple scenarios and output those variables. Now, the other aspect that you mentioned was the visibility perspective. So, like, working with Esri and ArcGIS and other tools to visibly show these and make it useful to use this data in a visual sense. That has also been done, as I showed a little bit earlier, NV Energy with that kind of sliding tool for looking to the future. Under future loading conditions. So that is a possibility. But I think there's also a lot of, exciting work currently ongoing here in making these as useful as possible, working with stakeholders to understand, yeah, well, what is the most relevant information for them? When do we need that information by? How do we incorporate it into working group sessions to engage on these topics of where to invest proactively in projects and things like that? So I think there's definitely a lot of excitement and knowledge to be learned there, but we're definitely on the right track.
One thing I'll add on that too is that we have several publications related to how hosting capacity maps themselves and hosting capacity analyses, things such as making sure they're regularly updated, because if they get stale and folks go to use them and they're not up to date, they can be lose the faith in it, if you will. I'd be happy to share some of those resources with folks after this presentation. Go ahead, Steve.
Yeah, just a couple of thoughts on your questions. I wish the utilities were on this call that they could help answer some of these a little bit more directly. But first, I think some elements of what you're talking about are being incorporated into the utility plans, like forecasted load, forecasted DERs, a range of assumptions there that are based on the SELT forecasts and other things from ISO New England. So some of that's being included. I don't think, I'm not sure though that they're planning on, they do have hosting capacity maps that are static, that are existing. I'm not sure if there's a plan to update those for this process, but I do think that would be a pretty valuable thing to have, to be, especially to be able to use with some of the public and stakeholder engagement that they are doing. They have been holding meetings with stakeholders. They have been holding public meetings as well. And I think those maps would be really helpful to help explain, where they might be planning on making investments and why, and where they're assuming DERs are going to get deployed. So I think that could be valuable information to have. Uh, I think the other thing that came up during the previous stakeholder meetings where we were talking about this is that it was around sort of some of the limitations of hosting capacity maps without like being able to have something that very clearly explains what they represent, especially the static ones, I think can be misinterpreted to mean like, oh, well, we can't put any more DERs in this location because of the grid is already at capacity in these places, and just a whole kind of discussion around how to make the information the most useful for people to use and not to misinterpret, and definitely having things that project out into the future under different kinds of scenarios, I think would be helpful in being able to understand sort of where those future investments might go. Thanks.
Awesome. Thank you, Steve. And I think we do have some folks from utility. I won't throw anybody on the spot, but I think we do have some utility staff here too. So if anyone wants to, if you all feel a space to share some of the complexity of that, by all means, feel free to jump on and do that as we continue with this. Right on. Thanks all. Shay, you want me to move on to the next slide?
Sounds great. So believe it or not, that was the lighter part of the conversation. So let's jump into what are when we get into the meat and potatoes of proactive host capacity analysis and its use case in proactive planning, aside from helping identify where the investments could be made, there is a really unique opportunity to use it in one of the most challenging areas of any related grid related process, which is cost allocation. So how do you deviate costs that are now not only serving rate base and customers for load, but is now also serving future DER customers? So big challenging questions ahead, but let's start with the areas of most tension, the areas that give us all headaches, but are also really exciting points for conversation and solution building. So first, obviously recognizing that there is a difference between a reactive and proactive investment. However, there is also some overlap. So reactive is obviously reminiscent of current interconnection practices. A new project gets proposed, an upgrade is identified because a threshold was breached, and we replace that infrastructure to allow that project to connect. However, and then proactive is looking ahead, looking at forecasts and saying where thresholds might be broken in the future, and then addressing them proactively. However, there is a proactive approach that has been deployed in reactive related investments. So in having something break a threshold, recognizing that that threshold or building just to above the threshold that allows that project connect may not be the most economical choice, but that you can build just slightly above that to allow the full utilization of capacity of the system, therefore allow more projects to connect at lower rates. So there are approaches that have been used, and I'm sure everyone is very familiar with, like the cost sharing 1.0 and I think now 2.0 in New York, where certain investments were incentivized or thresholds were being broken for major upgrades at the substation, and therefore a project would reactively pay for the upgrade, but then retroactively receive, payments back from other developers. So that was a way to make a reactive approach more proactive. So I think we're all familiar with that, but we're going to really be focusing today on the proactive approach. Second is the causer versus beneficiary, principle that has been applied across the cost allocation space. So we're all very familiar with cost causer pays in that reactive model. But now, since we're shifting to a more proactive approach, we want to think about the benefits that each upgrade provides to different ranges of customers. And recognizing that even a single type of upgrade, a single transformer replacement, single length of conductor replace can actually benefit multiple parties. And so that's where this process and this today's presentation focus on is differentiating and distributing those costs between those multiple beneficiaries. We then have planned versus forecasted. Recognize, I think we all know this, but just recognizing that there is a difference between a project that has not been built but is committed to be built versus a project that is just forecasted to be built and has no actual customers or people, designated to fill that capacity. So recognizing that there's a slight difference there that could be accounted for. Allocation versus recovery is a major one that is in a lot of these discussions. We're focusing today on allocation, but recovery and how costs are actually recovered by the utility, the time frames associated, the financing mechanisms used in that recovery, all of those are very important conversation pieces and have been worked through or currently working through in other working groups, but we won't be focusing on those today. Next slide. Other areas of importance to recognize and considerations to think about in proactive planning, risk versus certainty. So you're really trying to, in any proactive investment based on forecasts that could or could not happen, you want to reduce the risk associated with those. And there are several mechanisms that have been deployed or are currently being considered being deployed to reduce those risks. One is, that engagement, customer engagement and data transparency. That is a great way to do that. But there are also other mechanisms like a recovery window. I'll let you all read about this, but we can talk about this later. You should have access to the slides later. Cost caps that can be placed on certain upgrades, and commitment thresholds, how many projects have to commit before you make a certain investment, or percentage of the capacity built has to commit before you go forward with proactive investment. Things like that can all be used to reduce risk. Then finally, other items to be considered are capacity reservations. So reserving capacity for after proactive investments have been made for certain types of projects, or equity related considerations, both in capacity reservations as well as the distribution of cost, how to ensure that you don't create additional or worse off barriers for communities that have had unequal access to distribution infrastructure and to the clean energy future through creative, allocation procedures. So those are things that we're not necessarily going to touch on exactly, but I just want to highlight them because they are all important considerations. But let's map some of these together and show exactly where we're focusing on today. Next slide. So when we think of proactive host capacity planning, here's like a little bit of a word salad. You can see that there are a range of different topics that are considered. Forecasting is one we were talking about earlier. That's a huge, huge component and needs to be hammered in because that's the central area of risk. There's the procedures, regulatory procedures that dictate how people apply, how utilities conduct and transparently report this information to the regulators and to industry. There's the actual selection process, how you prioritize across a range of different projects that could be invested in. The recovery portion, there's definitions that need to be confirmed. There's coordination with reactive upgrades that need to be addressed. And then at the tiny corner, there's cost allocation. But if we go to the next slide, we see that cost allocation itself comes with a lot more as well, right? So we have the ability we have a decline policies that can be put in place, ability for someone to opt out of a cost allocation process in order to expedite their project and just pay for a major upgrade. There's customer class considerations, splitting those costs between types of load customers. If they have certain types of forecasted load growth that we want to make sure is more equitably distributed. We have application windows again, reduce risk. Commitment thresholds, again, a risk-related tool. And then we finally have co-benefit distribution. And next slide, and this is exactly where the PHCA use case comes into play, is the co-benefit distribution. So it seems like a very small part of a very big issue. However, it is often the most kind of I've not glossed over, but avoided topic in a lot of the proactive planning discussions. Talk about everything else. Everything else, there seems to have been frameworks developed and regulatory language developed and definitions developed and strategies in contractual law that allow us to like build up those sections of the procedures. But when it comes to actually recognizing that certain upgrades have benefits that extend beyond just one customer class or one customer type, that's where we get to some complexity. And that's where we think PHCA is the best use case for. So this is where we get into the meat and potatoes, our general approach, our PHCA proposal for how to use PHCA to help define and create a more equitable co-benefit distribution of cost. So this is an overview. Our general approach to this strategy is really bottom up, starting at the equipment, recognizing that again, a piece of equipment can have multiple beneficiaries. And so we have to start there in order to understand how it benefits those different parties. And that's going to help us identify load only versus DER only upgrades, because some equipment does kind of live in one area versus the other. But also then we have to think about identifying those co-benefits between those equipment. We also wanted to make sure that this framework that we developed is flexible in the upgrade decisions. So when a utility is proposing one upgrade, that they can actually consider multiple ranges while also not really having to think about the co-benefit distribution, which is kind of automatically baked into this process. And then again, cost allocation by beneficiary. This is a stage process. It starts first with defining equipment benefits allocation. We'll walk through each of these separately. Second, determining the need based on the PHC analysis. And then third, allocating the final cost according to the need. So we'll walk through those each individually. But real quick, next slide, you'll see just like a little mini, and click it one more time, Vaughn, a little bit benefit distribution between just a typical substation transformer, as you see here. So a transformer itself, just to define these co-benefits, has thermal capacity benefits. So that benefits DER and load. So they both have current, and are ejecting or absorbing current. And so you need something big to accommodate that current. There's redundancy benefits. So having an additional transformer is often a load benefit. So it creates system resiliency to, infrastructure failures that may occur. And that's often considered a very load or ratepayer specific benefit. And then you have backfeeding in particular. So loads aren't backfeeding, right? So if you have anything that allows a transformer to backfeed, which allows more DERs to connect, that's going to be a DER only benefit. So even from this short example from one substation transformer, you can see how there's categories, there's components of it that are both DER and load, as well as components that are load or DER only. Next slide. So Here's our benefit distribution kind of framing and definition. We came up with three major terms that we think help assess, a piece of equipment and dictate early on before you even have to make the decision about it being required, already allocate its internal costs across the potential beneficiaries that might be, that might be benefiting from it. So first we have our DER enabling upgrades. So these are upgrades that enable more DER to operate without direct benefits to load customers. Again, that is without direct benefits to load customers. And when a cost is associated or falls into that bracket, it is allocated to those DER customers, in this case, those future DER customers, through a cost recovery mechanism, which we can discuss a little bit later. You then have a capacity enabling type of upgrade or benefit, and that is an upgrade that actually benefits both load and DER, like the thermal upgrade we talked about with the substation transformer, and therefore cost and benefits are split between DER customers and the rate base. How that split happens is where PHC comes into play. We'll talk about that in upcoming slides. And finally, we have reliability enhancing. So this is an upgrade or asset that enhances reliability through redundancy or outage reduction, and that is specific and focused on typical distribution planning objectives, and therefore falls under the rate base beneficiary costs. And so all those costs, if they are reliability enhancing and don't have any direct benefits to DER customers, then they are going to consider reliability enhancing and go directly to the rate base. So those are the three categories. Now let's walk through a couple examples to just show this step one. Again, assigning benefits to step one, that's looking at a piece of equipment, looking at what aspects of it can benefit DERs, can benefit load customers, and which ones can benefit both. So first we have, as an example, a transformer replacement. So here the utility decides to replace a substation transformer. And this time they decide to just replace a single transformer at the substation, and they want to increase its size. And they also, because they recognize that penetration has been increasing in the area, they also want to install ground fault over voltage protection. People refer to this as 3v0. You might have heard it before, but they want to ensure that backfeeding of that transformer can occur and is not going to be detrimental to the health of the system. And so if we look at that, see, we've already assigned these. You see those different colors assigned across each of those different titles. And so we can really show and split up these costs pretty quickly. So for this example, ground fault over voltage protection, 3v0, is a DER enabling benefit. And that cost can be directly allocated to those DER customers in the future or through pro rata cost sharing mechanisms. We then have a reliability enhancing upgrade. This is the replacing of that transformer itself. So we consider like for like upgrades to be a reliability enhancing. So a piece of infrastructure that isn't benefiting, but being replaced, we believe is considered a reliability enhancing benefit. However, because that transformer was increased in size, then there is a delta above which that transformer cost has now been made, and now can be allocated to the capacity enabling category, which can be split across different people and different parties, different beneficiaries, DER customers and load customers, which we'll talk about a little bit later. We'll go through just a couple more of these and then move on to actually how the capacity enabling process happens. So here we have, utility decides to enhance substation reliability with 2 transformers. Again, the reliability, resiliency enhancing, that's going to be under reliability enhancing of a larger size. That's going to increase our capacity with GFOV protection. That's going to increase DER enablement. So next slide, you see those costs split yet again. Like for like still goes to reliability. Substation expansion, that's probably necessary to accommodate that second transformer. That's a lot. However, the benefit that DERs are getting from this, and that's actually going to be increasing the capacity of this particular substation in general, is going to just be the delta above the like for like value. I know it's going to be a lot, so I'll just kind of move forward. We can come back to this. And this final example is utility decides to install bidirectional controls on an existing regulator. So here there is no reliability benefit, there is no capacity benefit. It's all DER enabling, and so those benefits go directly to DER customers. So I know that was a lot, so let's go ahead and look at step two, though, which is another complicating component, but also really important. But thinking about how we actually now split up the cost of capacity enabling upgrades using PHCA. Next slide. Um, this is actually like a simplified diagram. We'll kind of skip over this, but we can come back to discuss those other options that we discussed before a little bit later. So we'll come back to this. Next slide. Again, reframing that this is where we're starting with, again, grid planning with PHCA. We're now trying to use and understand the capacity enabling value that capacity enabling benefit that was created and differentiate between what goes towards load customers and rate base and what goes towards DER customers. So how do we split between these groups? So let's go ahead, next slide. Okay, here we go. Everyone buckle up. Um, so how do we determine how much of the capacity enabling upgrade cost goes to DER customers versus the rate base? Um, Huge challenge again discussed in all the working groups that deal with this topic, and again is often like overlooked or often like put to the side to kind of address a little bit later. So here we have some little charts to kind of help describe and help hopefully give this visibility. So first at the top we have load. The top line is going to it basically determine what is existing um, um, Oh, actually, yeah. Let me pause there. Sorry, I had a message come through. Okay, we have at the top we have load, and we have first we have existing load, so that is what is currently existing in the system, and we have future load. So under a typical distribution planning process, we just be focusing on those two variables. Future load is higher. Therefore, we need to increase this capacity. The top line, load proactive host capacity, that is basically the value under those future loading conditions. What is the capacity of the current system for new load? Okay. So if you breach that value with new or future load, then you have to add capacity, right? So if that existing load line, as we see, is below load proactive host capacity threshold, but the future load capacity pushes it beyond. Therefore, added capacity is now necessary. An investment is now necessary. Moving on to DER, the same thing. We assess and understand what the DER host capacity is. So how much DER can the system accommodate? Because they have different inputs, DER host capacity is likely going to be smaller and different. So that's why you see that bar a little bit different than load proactive host capacity. So you have this capacity of the system. You have existing DER that has not exceeded that threshold. And then you have future DER that does exceed that threshold. Therefore, you need added capacity to the system. As you can note, both added capacity values are beyond what future load and future DER needs are. That's because you don't want to build up to exactly like the 1 kilowatt value above what you need. You have a standard size of a piece of equipment. It's likely going to exceed it by some amount. So we just kind of reflected that there visibly. And like as I mentioned before, load PHCA and DER PHCA are likely not equal due to different assumptions. Okay, so everyone take a breather. Um, Next slide. Um, so the thing I wanted to highlight first, before moving into the actual differentiation, is where DR dependability comes into play. So again, DR dependability looks at what existing DER is on the circuit, and in this case, if you're looking proactively, what future DER will also be on the circuit. Then considers, dials that down and says how much of that is going to be dependable during a portion of the time, and it's going to basically detract that from the load, future load scenario. So that value is now removed from future load, and therefore it's going to be served by, existing DER on the system. Therefore, if you look at it now, future load doesn't no longer, in this example, exceed existing capacity. Therefore, any upgrades in this case, if DERs, were to exceed the capacity, would only be on DERs, but we'll talk about that in a second. So I just want to highlight that DER dependability comes into play by offsetting future load because it's being served by DERs. Next slide. Awesome. Okay, now we're nearly there. Yeah, we're nearly there. And so now that we have these variables set and we recognize where the thresholds are and where they've been exceeded, we can now pull a few concepts away. We can pull some variables down for analysis into determining the capacity, the allocation of cost. So this is like our step 3. So on the bottom, we have our DER. And as you saw, the added capacity exceeds future DER by some value. So basically, the amount of added capacity by an investment enabled a certain amount of new DER growth, right? Some future DER could have been served under existing capacity, but some was enabled by the added capacity of the system. And that pulled down, and now that is enabled DER capacity. We can do the same for load. Next slide. Let's say that in this new scenario, DR dependability did offset some future load, but not all of it. There's still a need to add some capacity to accommodate that future load, likely a similar upgrade to the DER. And so we have that future load is now exceeding added capacity, and we click next slide, and we can pull apart again enabled now load capacity. So now we have 2 new variables. So using our proactive host capacity value that we determined through our assessment that we discussed earlier, and knowing what existing loading and DER conditions are, we now have determined how much enabled new DER capacity and enabled new load capacity would be made by a new investment that we're deciding on making. Next slide. And what this finally does is it allows us to break things into an equation. And so now that we have this investment and we know we've performed all of our host capacity analyses for both load and DER, and we know our enabled values, we can now actually differentiate and allocate these costs, or more so, distribute these costs between rate base and between DER customers. And so on the left side, basically, we're just saying that the numerator is how much capacity was added. New enabled capacity was made for both DER and load. So enabled DER capacity plus enabled load capacity. And then now we're just using a ratio. So for rate base, we're looking at the enabled load capacity compared to that ratio, that value. And then for DER, we're looking at the enabled DER capacity over that combined enabled DER and load capacity value. And that in total gives us the capacity enabling percentage of the cost. Next slide. We can now see what this looks like in final. So now that we have basically defined each of these different variables, we can now see that if there's a total rate base allocation of a particular upgrade, we have again those 3 columns: DER enabling, capacity enabling, and reliability enhancing. We can see how an investment that has 100% reliability enhancing but increases capacity to some percentage will have some X% allocated to capacity enabling, and then that total cost will then be allocated together. So I think we have another slide. We can go back to the transfer slide a little bit, and that can explain it again a little bit further. Oh, sorry, go back, Fawn. My apologies. But the same includes. So let me pause. So the total rate base allocation is going to be all of the reliability enhancing upgrades that happen. All the aspects of every upgrade of every piece of equipment that is reliable enhancing, 100% of that value is going to the rate base. And then any percentage that is capacity enabling defined by the calculations that we performed, and 0% of DER enabling. The opposite is true for DER customer allocation. So for total DER customer allocation, you're going to have 100% of the DER enabling, plus however much of the capacity enabling percentage was determined through the calculations using PHCA we discussed, and then 0% of lower reliability enhancing. So then that ends up being your total rate base and total DER customer allocation based on a ground up equipment focused and beneficiary focused allocation procedure using proactive host capacity. So I know this was a lot, a lot. So now we're going to move on to questions. And I would love you all to like point us to a slide because we can move back and forth to really describe this concept. But again, PHCA and ultimately is geared towards being able to just differentiate co-benefit distribution of cost between upgrades that could have, yeah, multiple beneficiaries, which is very common in grid-related infrastructure. Thank you.
Thank you, Shay. Yeah, what questions do folks have for Shay on this framework? We've got some kind of overarching questions we'll move into, but just before we do, it'd be great if, yeah, if there are any of these things that could use some more clarification, definitely be happy to pick Shay's big brain for it.
Has this been implemented anywhere?
It is not. No, it has only been proposed. Right now, territories like Minnesota have this question how to deal with this multiple benefit distribution, and they're kind of like, we don't know where to go with this. Like, what do we do here? While in other territories, I think like let's say the Eversource SIP process I highlighted earlier. I know they have some other processes as well, but in the SIP process, they kind of focused on a slightly the equation that they utilize for determining the distribution is just based on thermal levels and not on capacity. So it ends up being pretty disparate in terms of its distribution of cost for certain investments on DER customers. When I looked at the review, it's like almost all the cost or vast majority of the cost were not going towards load customers. It was almost all going towards DER customers. And even though those upgrades, like a new transformer being replaced, have significant reliability and redundancy benefits to distribution load customers as well. And so that has been a point of contention in certain areas and regions.
Thanks, Shay. Yeah, what other questions do folks have on the framework?
So Shay, it seems like this goes a long way towards achieving towards the equitability goal. Is there a way to, so I'm just a ratepayer, okay? So I don't know if this is a suggestion or a question, but it might be useful to show the difference between using this cost allocation model and what it would be without the cost allocation model in terms of helping ratepayers understand that this is more equitable. Does that make sense?
It absolutely does. I think it's a great suggestion. We did in separate documents have some of those comparison charts. We even created a little spreadsheet that kind of automated this with these different types of approaches, both a conventional kind of not reactionary, a less equitable approach, similar to what other territories have done. But we definitely want to make sure that when we release these issue briefs, that kind of calculator is built in and useful to show those comparison as well as maybe some comparison charts. So I really appreciate the suggestion.
But Steve, everyone's being so kind here, just treat each other like neighbors, just talk when you want to talk.
Yeah, and I feel like I've been talking too much, so I'm hesitant.
You're all great.
But nobody else is stepping forward. But yeah, I don't I'm not sure I can answer the first question, but I wanted to build on what Linda was just saying, which I do think, there's this part of the utility grid plans in Maine that have to go to equity, environmental, and EJ assessment. And I do think this could be really helpful to help answer some questions within that. There wasn't the joint comments that I was part of it that we submitted were very detailed on this topic about some suggestions for what they could include there. And the order from the commission left it a little bit more open-ended and sort of left it up to the utilities to propose something to address here. So I do think like on the cost aspect of this, it could be really helpful from an equity perspective, but I'm wondering if it can be used in other ways. You know, there's also the environmental piece of this. There's also the environmental justice part of this too, like how this could be used, or maybe it's a different methodology that would be used, but like where those investments are going to go, you know, are they going to go in an EJ community or somewhere else? Are there benefits that would come to those communities? You know, are there environmental impacts that can come out of this too if it's enabling more DER? Um, you know, maybe there's some benefits there. I don't know. I'm just asking the question for back to you guys if you could see it being used in other ways.
Yeah, I can get us started there. Most certainly. We'll talk about that a little bit more at workshop two, the equity implications of, cost allocation and PHCA and just grid planning procedures in general. Um, there are a, this is also a big topic in those other jurisdictions that are considering proactive approaches. Um, Usually, the typical procedure, honestly, has been to just avoid pro rata. So after you did this whole process, after you determine how much cost is actually going to DR developers, there's the actual, whatever pro rata value that's assigned to those interconnecting projects in the future. Basically a cost to interconnect based on those future those upgrades that were made to enable them. Um, and there's the most typical equity related practice has been to just have a cutoff for the size of project that would be subject to such upgrades. That has been the most typical. So saying like maybe uh, 20 kilowatts and below aren't subject to the pro rata cost. And then instead, um, the rest of the value is kind of subject to any projects larger than that to be recovered from those larger projects. So they have a slightly higher kilowatt value in order to accommodate those smaller projects. So that's a very light, less not very directed method. Other methods include um, processes that have yet to be fully adopted from the interconnection process, um, like um, interconnection cost if you have an interconnection cost cap, perhaps that's associated with this pro rata program, do you have some additional capacity or additional pool of funds for any small projects or projects that are being developed by community, BIPOC community, disadvantaged community? Do you have another bucket of money for them to supplement any additional cost above and beyond the pro rata share that were required for those upgrades that were made to enable, most of their project's capacity? Maybe they need a service transformer replaced that wasn't part of this program, but at least they have that cost still accommodated for. So things like that, but nothing's too direct, but we can definitely discuss that at the equity meeting to think about more cohesive strategies and how to deploy this on a wider range of issues. But looking for Marian Vaughn to have any comments.
Yeah, I mean, I would say the piece that applies in Maine that's closest to this is there's a cost sharing for interconnection of small DERs in Maine that has a cap on it. So we don't have anything akin to SIP as it relates to interconnection of DERs. But we do, oh, it's been a while. Hopefully Roman won't smack me for this one, but I think it's a $2,000 cap for projects that are 25 kW or less. That's kind of a shared cost across. It's not pro rata, but a fixed cost. But that cap ends at 2,000. And so, I think as Shay's talking about how equity might be integrated into that is to think about um, yeah, projects or customers where, not due to, they bought their house at a place not thinking about what the grid infrastructure was there. And, if the upgrades that are needed are much high, exceed that cap and then required something that would be prohibitive for that individual or that family to be able to connect. That might be one framework within what exists now. But I think, the long term, more durable gets to the point that Shay's talking about, Massachusetts has taken some steps on this. New York has taken some steps on this as well. So,
Yeah, and I would just add one, I think it's great to be continuing to think about the innovative ways that we could do this and states can do this. I think we're, definitely in the learning phase and we're still learning ourselves and figuring out how this can be deployed. But I do think there's, especially as we think about the risks in some of the proactive planning and what you're building out, you want to make sure that that's, as the least risky you can make it. And I think there are some very innovative things you can do on that other end of it where you're trying to also prioritize deployment in the areas that you're proactively building out. And so I do think like what Shay was saying would be really cool to say, we're proactively building out this area of the grid, this section of the grid. And so we're gonna actually have ways to help to direct, developers to those areas because they'll be beneficial for these different reasons, like whether it's consumer access, especially in those environmental justice communities, or like there are what are they called? The big depots, where it's a lot of emissions in one area, and making sure that those are more, you have some like EV chargers that can handle some of that, and there's less idling of trucks with diesel engines. Those kinds of things I think could be kind of on the innovative end on that side, where you're really incentivizing someone to build in specific areas. And I've heard people talk about this recently as kind of thinking of them as like hotspots. So just kind of thinking through that side of it is really, really good that you're already starting to think through how this can be used in that way. So I think that's a great start.
thanks, Steve. Yeah. What are other ways folks see, either challenges in applying this framework in Maine, opportunities, especially thinking through the timelines of where things are in the distribution planning process right now?
Can I like Steve feel like I'm talking too much, but
No, there's no talking too much. Go for it, Linda. We enjoy it.
my again, as a ratepayer who is not expert in any of these topics, it would be helpful to me to see a slide that says if a state decides that they want to implement this type of cost allocation framework, what are the steps that are taken in order to that happen? Is it software deployment? Is it buy-in from the CMP and Versant in Maine's case? Is it regulatory changes? Is it the Public Utilities Commission? I just don't have a picture in my head. I can't think of what the challenges are because I don't even know what the steps are.
You want to take a shot at that one, Shay, in terms of kind of how this is typically ordered?
Yeah, absolutely, absolutely. Um, yeah, because these steps I think are pretty deep. The three that we highlighted are very there's a significant amount of depth in them, and therefore I think we need a little bit more um create a little more transparency and conciseness across maybe a wider number of steps that have a little bit more narrower objectives. In general, just to highlight what those steps are, um, the first would be the assigning benefits stage. Again, that stage is really focused on a utility-centric approach with maybe some industry review. All it does is really when a utility engineer in my past utility engineering days, having a range of investments that we and choices that we make on a day-to-day best on a day-to-day um, cadence. So whether we're deciding to replace a transformer, replace conductor, whatever, replace a recloser, like having all the equipment that we typically would use and would replace, and with all their cost data, like a huge cost table of all the major investments that they would be conducting, and then to break those cost data points that are provided. Um, in that like unit cost guideline that utility probably has in behind closed scenes, would be then breaking those costs out between DER only related investments and reliability enhancing benefits. And so if it's something like a redundant investment, it would be under that redundancy enhancing or reliability enhancing, or if it's a DER specific upgrade like 3v0 would be there. And so you could basically separate a lot of these upgrades, these equipment upgrades, pretty quickly into what's going to be charged to DER customers versus what's charged to rate base. But then you can start then highlighting where the challenging areas are, where the capacity enabling ones are, and that's where we can have like future discussions about how to deploy PHCA to that. So that's step one, is like really identifying what equipment, kind of can be separated across those major beneficiary categories, and
So is
highlighting the
this,
ones that need to. Oh, go ahead.
oh, sorry, Shay. So is this, I'm 3 steps higher up than what you're talking about. So what you're saying is the companies, the utilities are making decisions about what to do. And we're trying to encourage the utilities to take advantage of tools that are provided by IREC. Is that what we're trying to do? How do they get the tools, and how do they get the information, and how do they incorporate it into their business practices? That's what I'm at. I still don't have like the really, really, really high level view of, it's kind of like if somebody asks you, how do you play baseball? And you start explaining to them about what a double play is. I need back three steps back from everything that you said about the framework and the cost allocation seems great to me, but are we trying to change the decisions that are made by the utilities? Are we trying to make the decisions are we trying to change the regulations in the state? Are we trying to influence the Public Utilities Committee? Are we trying to convince ratepayers that this will be helpful to them? I don't understand where of those 4 places we're talking about.
Absolutely. Totally fair. Totally fair. I'd say there's elements across all those ranges, but the ones I would say are primarily like driven in the regulator space are data transparency requirements on cost related data to infrastructure. That's unit cost guidelines and that are more detailed, that can then be discussed in this larger context of this cost allocation practice. So that's an enabling component. So data transparency on cost, a regulatory reporting requirement.
Okay.
Then there would be the deployment or requirement of performing PHCA and publicizing those, another regulatory requirement that would have to be issued. Then, so those are the 2, I guess, probably fundamental enabling concepts, because you need that information to perform any of these assessments.
Right. Okay.
There would then, and maybe Vaughn and Mark can weigh in on this as well. There would have to be, as is being performed in other states, various working groups conducted to determine how best to make the decisions across the proactive planning landscape. So remember, this is one very small, narrow component, the co-benefit cost allocation component. But we have the entire capacity planning objective, which requires its own regulatory process, its own procedural language.
Okay.
And so that is probably a pretty cohesive, collaborative working group, session and group of sessions and meetings to build upon what has been done in other states, and develop a certain particular framework, and contractual language and requirements and whatever it may be, for proactive planning. So those are all enabling of these then this larger discussion, which involves probably a lot of back and forth during a proceeding on this topic,
Okay.
an addition to the proceeding process where cost data is now shared, and now cost decisions are now made across those benefit categories. So you need those 3 enabling regulatory requirements in order to then spark the discussion that would allow for this kind of co-benefit allocation discussion. Hopefully that got us somewhere.
That helped a lot.
And I can add to this, Linda, because I think and correct me if I'm wrong, what I hear you hear you thinking about is like strategically, if someone's bought into this, how does one make it happen? Is that in the
Yes, yes,
picture? Yeah.
exactly. Like, who do you talk to? What mechanisms do you use to, so just knowing that we're talking about regulatory processes helps a lot because, I know who the regulators are. That helped a lot.
Yeah, and I'll say, I mean, I think how we're here right now is a good illustration of how this happens, right? The legislature sets a directive, the commission's charged with carrying it out, and then a variety of stakeholders come to the table. And I think change is always triggered by, someone feeling compelled to do something, and that can be utility sees it in their business plan over the long term, and you're talking with the right people within the utility. It can be that the state says utilities, we need to do this, and then it's on the commission to do that on behalf of the public. As I look at who's signed up for this, both who's here and who's going to be receiving the recording of this, I think these are the places where it starts, right? It's the informing and understanding the frameworks and how these frameworks best serve the various parties that are at the table, right? And so, we have members of the Public Advocate's Office here who advocates on behalf of ratepayers generally. We have folks from the commission who are here who are working to figure out, as they're working with the utilities and the public, how to best get the outcomes that work for Maine ratepayers and Maine generally. And then we have utilities here at the table as well. And some of this is a matter of folks that are on this call, I know, are super busy people that are doing their best to get things done. And part of why IREC exists is to take the lessons from elsewhere that might be applicable to the challenges that are trying to be solved in states around the country, so that it's more accessible. And so I think the conversations that we have here and continuing this conversation, make my big plug for coming to the next session, which Mario will talk about shortly, but also just continuing the conversation offline, to continue these networks. One of the beautiful things about Maine being a small state is folks are readily accessible. I think it gives us the ability to solve complex problems in ways that are harder elsewhere. And so this is a great start. And I think this conversation has been awesome in helping move that along. And hopefully it's been helping serve the folks who've been doing some heavy lifting on this so far. And with that, I'll kick it over to Mari for next steps.
Yeah, and yeah, thank you so much to everyone for joining. We just want to make sure that we're so thankful for you being here today, and hope that you'll consider joining our next workshop that's going to be on June 26th. It's the same time frame, 1 to 3 Eastern, and that one's going to focus on how do you center energy equity within grid planning processes. Michelle, if you're able to share, you may have just done it, the registration link, if you'd like to go ahead and register. We'll also send it in the follow-up email after this that includes the recording. We'll send that out to everyone who registered. And Shay mentioned this. I don't actually think I mentioned this in the lead up. We are developing a couple of issue briefs on this. And that last point, Linda, that you had on how to make sure you understand what do you need to do is really important. And that's something, Shay, you and I can think about how to make sure we're incorporating that piece of it, so that folks understand, okay, where is this happening? Who is the audience for this? And what kind of advocacy needs would there be to make something like this happen? So thank you for all of your comments and questions, and feel free to follow up with this as well. I actually don't think I included our emails. I was the one who sent out the registration or the invite, so feel free to reach out to me, and then I can connect you with Shay or Vaughn, or we'd be happy to get on a call too if you want to discuss any of these things separately. But thank you all for joining. We really appreciate it. And yeah, I think unless there's anything, Vaughn, if there's anything you want to close with, I think
Nope. I would just say, and as Mari mentioned, the next piece will be on centering equity in the grid planning process. So, if you have specific things that you're looking for and you're like, oh, I want to make sure you all focus on this, let us know via email. We have a pretty broad sense of what that is, but definitely want to make sure that this is serving the needs of the folks that are here. So thank you all so much.